Hi everyone, glad to have you all back. Good morning, good afternoon, and good evening to all those who joined us from across the world. I'm Manish Krishnan, Head of Marketing at QKS Group. Once again, I would like to welcome you all to today's session, Why Enterprise Data Still Isn't Trusted for AI, where CDOs are hitting real constraint in 2026. Thank you all for joining us. Over the past few years, enterprises have invested heavily in cloud data platforms, analytics modernization, and AI initiatives. Data is more valuable or more available than ever. Yet, when it comes to scaling AI with confidence, one challenge continues to surface, which is nothing but trust. In 2026, the constraint is no longer access. It is whether enterprise data is reliable, governed, explainable, and operationally ready to support AI driven decisions at scale. Many AI pilots succeed in controlled environments but struggle in production, where fragmented ownership, lineage gaps, inconsistent quality, and regulatory pressure expose structural weakness. Today's session is not about tools, it's about operating models, governance design, and AI accountability. We'll examine where trust breaks down across the data to AI lifecycle, why traditional data modernization efforts are falling short, and what CDOs must redesign to make AI dependable and defensible at enterprise scale. I'm pleased to welcome Amandeep Singh Kanuja, Associate Director and Principal Analyst here at QKS Group. Along with Amandeep, we have Arun, Principal Analyst at Data Management Domain here at QKS Group. Together, they will unpack the real constraints data leaders are facing and provide clarity on what must change in 2026. We encourage all our attendees to drop your questions in the Q&A section below, and we'll address all your questions in the end of the session today. With that, I hand it over to Arun, and over to you, Arun.
Yeah. Thank you, Anish. And thank you, everyone, for joining today's session. So, as we all know, most of the enterprises have invested heavily in cloud migration, let's say modern data platforms and analytics, right? But as one of our research confirmed, trust, not data values or access, has become the real bottleneck for AI. So, like for example, recently when we concluded one of our studies, we found out that fewer in one in four AI pilots successfully reach production. This is mainly due to low trust in AI outputs and poor data quality. So, in short, boards or data leaders they now view trust as an executive level KPI. So, like AI cannot succeed without trusted data or explainable data. So, let's start by grounding the discussion in what we are currently seeing across enterprises. So, here in this slide, you can see, on the left of this slide, you see what we describe as AI momentum, right? So, AI adoption is accelerating rapidly across almost every enterprise function. So, what began as an experimentation is now moving into operational deployment, and AI is being embedded into pricing decisions, let's say customer engagement or supply chain planning and risk evaluation. So, at the same time, most organizations they have actually already completed the significant infrastructure modernization, like the cloud migration, the modern data platforms, and integration layers. They have actually created all these technical foundations required to scale AI. And because of this, the expectations of executives it has been increased significantly. The leadership teams, they are no longer asking whether AI should be adopted. They are asking like how quickly it can deliver the measurable ROI. So, from a capability perspective, enterprises appear ready, but when we look at the right side of the slide, a different reality emerges. So, data trust is not scaling at the same pace as AI adoption. That is one of the biggest challenges they are facing. And confidence in data reliability, let's say lineage visibility, and governance maturity is lagging. So, most of the organizations they have the engines required, and they have the AI models, and they have the fuel, which is the data, and they have the infrastructure, but they lack sufficient quality control to ensure that the fuel, which is the data, does not damage the engine. So this is actually what creates as a capability gap. So the AI ambition is increasing faster than that data reliability, and the gap becoming dangerous because the AI amplifies the underlying data issues rather than correcting them. So the key message here is that the challenges that enterprises face today is not lack of AI capability. It is the mismatch between how fast AI is scaling and how slowly trust mechanisms are evolving. And that leads us to the next question. How did we reach this situation despite years of data modernization? So over to the next slide. Yeah. So to understand the trust gap, we need to look at what modernization actually solved and what it didn't. So on the left of this slide, we can see what modernization is actually achieved. So centralized cloud platforms solve the problems of scarcity, of course, but the storage become abundant. So and the data becomes accessible across the organization. And the self-service analytics allowed business users to consume data without heavy IT dependency, and architectures were optimized for analytics and for reporting and for dashboards. And this was actually a major success, let's say. But organizations moved from not having enough data to having data everywhere, but the access and trust that are not the same thing anymore. So on the right side, you can see the trust gap that emerged as a result. So AI demands something fundamentally different from analytics. And what AI records is context, explainability, and reliability over the time. And models fail silently because the assumptions change. So unlike dashboards, AI does not tell you when inputs become unreliable. The second issue is architectural. So most of the data pipelines were designed for speed and volume. The assumption was that quality and governance would evolve organically as adoption increased. So in reality, trust was assumed, not engineered. So organizations modernized the infrastructure, but governance models often remained rooted in legacy era. So the policies remain manual and the lineage visibility remained incomplete, but the context was lost across all transformations. So what we see today is not a failure of modernization. It is actually a mismatch between what modernization was designed to achieve and what AI now requires. So modern platforms, they increased the access, but the trust requires continuous reliability, the context, the accountability, let's say the capabilities that were never part of the original design code. So and this becomes critical when we look at how AI itself has evolved. Over to you, Amandeep.
Yeah, thank you. So Anish, can you move to the next slide? Yeah. So thank you so much, Arun. As you shed some light on how the resolution versus the trust gap is actually, and now I would love to take you guys through that how AI has actually moved from insight towards execution. So in this slide, I want to explain why the trust gap we all have been discussing has suddenly become both like visible and urgent across the enterprises that we're talking today. But to get to know this, we need to step back and examine the evolution of enterprise data usage over the past 2 decades. Because from there, we have seen a clear progression through distinct stages, each of which has increased the role of the influence of data and decision making towards the visibility that it take into the AI systems. So let's start with the first stage. The first stage was reporting. Now, here the primary objective was visibility because organizations used data to answer the questions. And what happened during this phase, what was actually dashboards and reports used to provide historical insight, and the role of data was largely just informational, not much than that. In the second stage, was analytics. Now, where the focus actually shifted towards understanding, casualty, and organizations started to ask questions like, why did it happen? And all these insights became more advanced. Human interpretation still, remains central to this decision, which mean that the context and judgment acted as safeguards in the hands of humans. But still, they were in this era, it was more related towards understanding the causality of the data. In the third stage, where we introduced AI and ML, it actually enabled predictive capabilities. Now, where organizations actually move from insight towards foresight because they became predictive that what will happen next. And even at this stage, however, AI outputs were often advisory in nature. This supports decision they used to just support decision rather than execution. So they used to support with explainability, lineage, but there was no execution in that. And today, I think we're entering a new and more consequential phase, because now what we describe as the current frontier here is where AI actually moves beyond prediction into execution. And actually, it becomes more increasingly into an autonomous action that it will perform. And the AI systems and automated workflows, I think they're no longer limited to generating recommendations now. They are actually beginning to take direct action with operational processes, and which influences pricing, risk approvals, maybe supply chain adjustments, customer engagements, without actually requiring any continuous human interventions. And it is this transition actually from insight to execution that fundamentally changes the risk equation completely. Because when humans remain actively involved in the decision loop, errors and inconsistencies can be easily identified and corrected through contextual understanding of human experiences. However, as decisions have started to become more automated and have also scaled across thousands of millions of transactions, even small data inconsistencies can produce amplified consequences now, because things are very correlated. And this is why the trust requirement curve on this slide increases as we move from reporting to predictive and autonomous systems, right? And in pure informational environment, minor inconsistencies may be tolerable because they are interpreted and validated manually. But in predictive and autonomous environments, all these same inconsistencies that were okay manual can translate directly into operational disruptions, maybe financial exposures, compliance risk, or reputational damage. So the critical message here is that AI creates new data problems. Rather, AI magnifies the impact of existing data weakness. So as organizations shift from data for insight to relying on AI for execution, trust is no longer a desirable attribute. I think it becomes a prerequisite for a safe and scalable AI deployment. And I think this is urgency here is very precise, because why we now need to examine this more closely, where trust breaks, within the entire data to AI lifecycle, and why traditional governance and operating models actually struggle to keep the pace up with this new reality. Yeah, over to you, Arun.
Yeah, next slide, Anish. Yeah, so to structure the conversation today, we will walk through 4 connected ideas. So first, why enterprise data still fails trust tests even after years of modernization. Then second, where CDOs are encountering real constraints, not theoretical ones, but operational realities that appear during AI deployment. Third, how AI fundamentally changes the definition of data trust itself. And finally, what this means for operating models going forward. Because the next phase of AI success is not a technology problem. It is an organizational and operational design problem.
So thank you for Arun, for suggesting the complete discussion. So before we move on, I have a small poll to run so that we can gather your insights and understand where we are. So just I'll bring up the poll, and I think you guys can see the poll, and would love if you could answer, and then we could discuss so that we know that we are aligned on this problem as well. So yeah, I see many options going towards data quality. That's great. So majority of them are going towards data quality. Perfect. Yeah. Just giving one moment so that everyone can hop in with their answers, and then I might publish the result, and then we can move ahead. Perfect. Okay, just let me, yeah. So as we just discussed, I think data quality again is plays a very big role. So the ultimate agenda, and even what we saw is typically across the enterprises that we're talking, is that organizations initially point to data. More data quality is a problem, but when we do deeper discussions, quality actually turns out to be a symptom rather than the root cause, because quality issues often originate from lineage gaps, as simple as that. And governance issues often stem from fragmented ownership. And to be very honest, when we use AI actually exposes all of these simultaneously because it depends on the consistency across the entire life cycle, not just on one point, right? Anish, if you can move to the next slide. Perfect. So here, let's try to understand the architectural mismatch. What we mean by that. To understand why enterprise data continues to struggle in reliably supporting AI initiatives, we just let's step back and examine the foundational assumption under which most enterprise data platforms were originally designed and implemented. The majority of enterprise data architecture in place today were actually built during what can be described as an analytics. You know, we call it as analytics first era, where the primary objective was consolidation, bringing together data from multiple operational systems into a centralized environment so that it could be queried, visualized, and reported on efficiently. Now, during that period, success was actually measured by large accessibility and availability rather than other decisions, because organizations evaluated their data platform by asking questions such as how quickly can data may be available to users, how many business stakeholders can access it, how frequently can reports be refreshed or dashboards updated, all this context. Within the context of analytics, the operating model proved highly effective. However, with the advent of AI, now AI introduces a fundamentally different requirement. Traditional analytics environments are inherently more tolerant because human judgment remains embedded in the decision making process. When a number appears, usually on any dashboard, a business user can question it, apply contextual knowledge, maybe validate assumptions, and also adjust the interpretations before acting on it. In most cases, decisions are not executed automatically based solely on single analytical output, but AI systems, by contrast, operate under very different assumptions. So they consume data continuously to respond automatically to patterns detected within the data and depend heavily on consistency in their inputs. So it has to flow continuously inside. Because it does not interpret ambiguity, AI systems morely tend to amplify it, because when even small inconsistencies in input happens, data can propagate through models and influence large volumes of downstream decisions. So if I can put this in a more better way, let's take an example. For example, if we observe in a retail environment, a retailer may develop a pricing optimization model trained on historical sales, performance, promotional data, and a lot of inventory levels. Now, during testing the model, uh, the model performs exceptionally well, largely because the historical data set reflects relatively stable and well understood business conditions. However, once the model is deployed into production, with subtle upstream changes, you will see the very subtle upstream changes actually begin to occur, because product categories may get reclassified to align with new merchandising strategies. Promotions may actually log differently because across regions differentiation, and inventory updates may arrive at slightly inconsistent intervals due to operational variations that the store may have. Now, individually, each of these changes appear minor, and it does not trigger any technical failure. But data pipelines continue running successfully, dashboard display expected values, and from an infrastructure standpoint, everything appears very stable. Yet, collectively, these small shifts alter the statistical distribution of data entering the model, gradually moving it away from the patterns on which it was actually trained. Now, the platform continues to report success because job is completed and data flows without interruption. However, the AI outcome begins to drift and lose reliability. Now, this is what I refer as architectural mismatch. Data platforms that were optimized for analytics implicitly assume trust once data enters the system and passes the initial validation checks. Now, in AI environment, on the other hand, require trust to be continuously validated as data moves through transformations, feature engineering layers, and routine executions. And it is It is a precise mismatch that leads many data officers today to observe that despite having modern platforms and robust infrastructure, AI reliability still feels inconsistent and difficult to defend at scale because of the architectural mismatch. So, if we go to the next slide, next slide, uh, I want to here I want to tell you about that where actually the meaning gets lost. Another important realizations for data leaders is that trust rarely breaks at the point of ingestion. Even though it's where most governance and quality investments tend to concentrate. I think most of the organizations allocate significant resources towards ingestion level, such as many controls, such as schema validations, completeness checks, duplicate detection, structural conformity, all of which are necessary and very valuable safeguards. However, these controls addresses only the initial stage of the data life cycle rather than its full journey. So in practice, trust erosion typically occurs and it gradually moves as data moves downstream through multiple transformation layers, where it is joined with other data sets, aggregated, standardized, renamed, maybe reformatted, and occasionally simplified to optimize performance or usability. Individually, each transformation step appears logical and justified within its local context. But as you move over the time, the cumulative effect of these modifications gets too weak. And it weakens the connection between the data and its original business meaning. And this phenomenon, I think, becomes very particularly visible in complex environments such as financial services, because here data fields often carry nuanced interpretations. Uh, Consider, for example, a field such as customer income. Now, which is at the source level, maybe represent several distinct concepts, including declared income provided by the customer, maybe estimate income delivered from credit bureau data, or inferred income calculated through transaction behavior analysis, each serving a different analytical or operational purpose. Now, as data flows through transformation pipelines, as I mentioned, these distinctions are frequently normalized into a single consolidated field for more simplicity. It will, for more simplicity, more reporting efficiency, or model convenience, thereby removing the contextual qualifiers that originally differentiated them at the start of the data entry. And by the time this consolidated field reaches an AI model, the original semantic distinction have effectively disappeared. And models treat these values as equivalent inputs, even though their underlying meaning and reliability may differ substantial. From a technical standpoint, nothing appears to have failed because pipelines have executed successfully, data sets load correctly, and even validation check has passed. Yet, from a trust perspective, the semantic integrity of the data has been meaningfully shifted. And this is precisely why lineage and contextual metadata are, I think, no longer optional governance documentation, but are increasingly becoming operational requirements. Because as organizations must understand not only where data originated, but how its meaning has evolved across the transformation before it is influenced with AI-driven decisions. That was the entire point.
Yes.
Anish, if you can, yeah.
Yeah. Now let's speak about the pilot illusion. So, why AI appears successful before it fails, right? So, one of the most consistent patterns we observe across enterprises is what we refer to as the pilot illusion. AI pilots almost always succeed, and this is not because organizations are intentionally misleading themselves. It happens because pilots operate in controlled environments. So, data is curated and edges are removed, and exceptions are minimized. Teams manually validate inputs, but the environment is optimized for experimentation rather than operational reality. So, and the environments, these enterprise environments, they are actually hit very different. So, once AI moves into production, variability increases dramatically. So the census it may fail intermittently, and the data entry practices differ across regions, and there are a lot of external factors, and this introduces a lot of noises that was never present during training. So these AI systems, they encounter scenarios it has never seen before. So organizations often respond by retraining models repeatedly. No, but retraining addresses model performance, not the data generation inconsistency. So what AI actually does in this stage is expose operational data at scale, but many organizations interpret declining AI performance as model failure. So in reality, AI is revealing reliability issues that already existed but were previously invisible. This is why AI scaling becomes a trust problem rather than a model problem.
Perfect. Anish, can we move to the next slide? Yeah, and this is where I will take. I want to talk that how important it is for data leaders to actually make a trade-off between uh, speed, risk, and control. Because as AI innovations are moving faster, it's very important that we need to keep up with the pace, but we need to be in control, and we also need to manage the risk because we are the ones who take care of data. And I have always believed that data is what gives AI the power, because garbage in, garbage out. So if you provide clean data, you'll get clean answers. So coming back to the slide, at this point, I think most CDOs recognize the issue. So they know that awareness is not the problem, but execution is. So the environment CDOs operate in today is fundamentally different from even 5 years ago, because business team expect faster AI deployment. There is competitive pressure demands that continuous innovation. At the same time, regulatory and risk expectations are also increasing with the growing pace of AI innovation. And CDOs are effectively operating between these all three competing forces. So AI team, I think it requires speed and flexibility. Risk and compliance teams requires assurance and control, and business leaders expect measurable outcomes. Now, traditional governance models assume slower change cycles. Uh, but as I think AI introduces continuous change, new data sources appear rapidly. Models also evolve very frequently, and data usage has expanded across the functions. It's not at one layer, and this creates structural tensions where I think governance mechanism was designed for stability. It's actually struggled to keep up pace with the dynamic AI environments. And this tension is one of the primary reasons enterprise AI initiatives stall after initial success. Uh, uh, Anish, if you can just move to the next slide. Yeah. So here I want to talk about why actually manual governance does not scale. So traditional governance approaches rely heavily on manual processes. So data steward, used to review definitions periodically, and policies are documented and enforced through approvals. Quality checks occur at predefined intervals, and I think these approaches worked when data usage patterns were predictable and change cycles were slow. Now, AI changes this fundamentally. Data is consumed dynamically by models. Transformation continuously occur, and new use cases emerge very rapidly. Manual stewardship cannot scale at this speed. So, if I have to say, consider a global insurance organization, introducing AI into claims processing. New data sources such as images, documents, external risk signals are introduced frequently. Each additional changes now how actually the data is interpreted. If governance relies on manual review cycles, I think governance will always lag behind usage. Now, trust becomes the react. Now, here in this scenario, I think trust actually becomes reactive, then it has to be proactive. And I think this is why governance increasingly needs to behave like engineering. It needs to behave automated, continuous, and embedded directly into the workflows. And with this, I want you to get your attention towards data trust. Anish, if you can move to the next slide. Yeah. So data trust has no single owner, right? And because at this point in the discussion as we move, I think from architectural challenges to something even more fundamental, and I think that is ownership. One of the most overlooked reasons enterprise data trust breaks down is that no single function actually owns trust end to end. If you look at this slide, what we are trying to show here is not a failure of an individual team. Each function is actually doing its job correctly. The problem emerges at the hands-off between the functions, like I earlier mentioned. So let's walk through this from left to right. So data engineering teams primarily own the infrastructure reliability, and their success metrics are uptime, data movement, latency, and scalability. From their perspective, if pipelines are run successfully and data arrives on time, the system is functioning correctly. Governance teams, they focus on compliance, accessing policy, privacy rules, retention requirements, and regulatory adherence. Their objective is to ensure that data usage is controlled and auditable. Then there is AI and ML teams. They focus on model performance, accuracy, precision, scoring, and prediction quality. Their responsibility is ensuring that models perform well against defined metrics. And finally, the business units. They focus on outcomes, revenue impact, and operational efficiency more towards customer experience. Now, individually, each layer is optimized, but trust does not exist within a single layer. Trust exists across the entire chain. This is where the accountability gap emerges. For example, uh, if a model produces an unexpected decision, data engineering team may say the pipeline ran correctly, and governance may confirm policy compliance. AI teams may confirm model accuracy. Business team may say that outcomes may look wrong. Now, everyone owns a piece, but no one owns the reliability of decision itself. And this is why you see the bottom row on the slide. It is end-to-end AI trust that effectively owned by no one. But in many enterprises, trust erosion actually happens precisely at hands off. Information loses context as it moves from infrastructure to governance, and from governance to modeling, and from modeling to business execution, all in a loop. The result is predictable. When issues arise, root cause analysis become slow and fragmented. Each team investigates its own layer, but the systemic problem remains unresolved. And this is why leading organizations are beginning to rethink ownership models. Instead of siloed responsibility, they move towards shared accountability around use cases or data products, where trust is treated as an end-to-end outcome rather than a departmental responsibility. And once ownership becomes fragmented, the next challenge naturally follows. Uh, Even when teams want to explain decisions, they often cannot. So, trace the data and how data actually becomes an AI input. That brings us down to our second problem after trust, that is traceability. And next, we could just move to the traceability slide. Yeah, thank you. So now with the second problem, let's examine what happens technically once data begins moving through the enterprise system, because this is where a pattern consistently emerge across organizations. A gradual loss of explainability as data travels from its raw source to the final model input. And at the beginning of life cycle, data is typically well understood, as raw operational data usually has clear defined ownership from the start, documented business meetings, and an identified system of origin. However, I think as same data moves through multiple transformation layer, including aggregations, normalization steps, feature engineering processes, enrichment logic, or cross-system joins, the level of complexity increases significantly. Over the time, cumulative effect of these transformations makes the original business context increasingly difficult to trace, creating what we describe here as complexity overload. In many enterprises, there are dozens, sometimes hundreds of transformation layers that have evolved incrementally over the years of analytics, reporting, and maybe requirements for optimization. While each transformation often makes sense in isolation and solve a very local problem, collectively they begin to obscure the original intent and meaning of the data. A second and important issue is the presence of hidden logic between the traceability. So many transformation occurs within Python script, embedded SQL procedures, feature engineering notebooks, or automated pipelines that are not fully captured by traditional lineage tools. Although the logic technically exists within the system, it is not always visible or standardized or easily auditable at scale. So I think as a result, when a model produces a particular output, tracing the precise data path, including how specific attributes were derived or modified, becomes extremely challenging. And this challenge becomes even more pronounced as organizations increasingly incorporated AI generated or synthetic data into their workflows. As Because as AI systems begin generating features, embeddings, labels, or maybe even augmented data sets, provenance can become very blurred. Without robust tagging mechanism and detailed lineage capture, it becomes difficult to clearly distinguish between original source data and derived AI generated inputs, which significantly complicates transparency and accountability at a very bad level. But if you see over the time, this accumulation of complexity can also result in what we call a traceability dead. Now, this dead end uh, actually comes from where the final model input can no longer be reliable, linked back to specifically raw records, transformation traps, or ownership domains. And this has very real measurable consequences. First, the consequences, as it's mentioned, first, explainability suffers as organizations struggle to justify AI driven decisions. I think second, debugging becomes disproportionately time consuming because root cause analysis that should have ideally taken hours can stretch into weeks while teams attempt to manually reconstruct the fragmented data flows and undocumented transformation. Third, and perhaps most critical, trust begins to erode as business users gradually lose confidence in models whose outputs they cannot clearly interpret, validate, or defend. Just imagine like using chat gpt and you're not getting your answers for days, months. You're like, oh, chat gpt is bad, and you just shift to another thing. So that's it. That's the level of trust erosion it comes upon, right? uh, the key insight here is not primarily a model transparency issue. Rather, I think it's a data lineage and transformation visibility issue that predates the model itself. So AI simply makes the problem more visible, and when organization describes AI system as black boxes, the opacity often originates upstream in the data pipeline rather than within the model logic. And for this reason, solving data trust challenge requires comprehensive visibility across the entire life cycle, from raw data ingestion and transformation to model execution and till the final decision outcomes. I think, yeah. Arun, over to you.
Yes, like Anish. Yeah. So now let's talk about the AI outcomes. Like how AI outcomes rarely improve the upstream data. So at this point in the discussion, it is important to recognize a pattern that correctly prevents many AI initiatives from maturing. AI outcomes rarely improve upstream data systems. So when AI models fail, drift, or produce unexpected results, organizations often respond locally rather than systemically. So the model is retrained, and if a new feature is added or a new feature is adjusted, and a threshold is tuned, and a new patch is applied, the issue appears to be resolved, but at least for temporarily. But the original data issue at the source system frequently remains unchanged. This is why the first box on the slide highlights that data issues persist. So quality problems in operational systems often go unaddressed because model levels fixes are faster and easier to implement rather than cross-system corrections. So instead of improving the foundation, organizations compensate at the model layer. So the second issue is the absence of feedback loops. So in many enterprises, there is no automated mechanisms that pushes model insights and error signals or anomaly patterns back into the data engineering workflows. So when a model detects bias or when a model detects this drift or unexpected distributions, that intelligence often stays within the AI team. So it does not translate into structural improvements in upstream pipelines or source systems. So without structured feedback loops, AI becomes a consumer of data, not an improver of data. So now the third problem is late failure detection. So data quality issues frequently surface only when AI model produces a wrong or suboptimal business outcome. So by the time leadership notices, the impact has already occurred, whether it is revenue loss or operational efficiency or customer dissatisfaction, let's say. So at that point, the corrections become reactive rather than preventive. So, and this leads to these three consequences. First one is trust erosion. Every repeated error that should have been fixed at the source itself gradually reduces confidence in AI systems. So businesses, the stakeholders, they begin to question whether the models are dependable itself. So the second one is reactive corrections. So teams spend significant time in firefighting specific model failures instead of strengthening systemic data health. So resources that are consumed by short-term remediation rather than long-term resilience. And the third one is blob scaling. So AI initiatives stall because data readiness does not improve over the day. Even as models evolve, the underlying data foundations remain unstable. This actually limits the enterprise-wide deployment. So the core message of this slide is simple, but it is powerful. AI does not automatically create a virtuous cycle of data improvement. Without so AI does not automatically create a virtuous cycle of data improvement. Without deliberate feedback mechanisms that connect model outcomes back to upstream systems, organizations remain trapped in a loop of patching symptoms rather than fixing causes. And if data foundations do not improve continuously, AI reliability will never scale sustainably. So this is why feedback loops are not optional in AI environments, but they are very essential for turning isolated model performance into a systemic data maturity. Next slide, Anish. Now let's focus on how trust is moving from data quality to decision defensibility. So up to this point, we have discussed where trust breaks, like the ownership fragmentation, loss of traceability, and lack of visibility across the data to AI license. So this slide marks an important transition in the conversation. So what we are seeing across enterprises is not just a tooling gap or governance gap. It is actually a shift in how trust itself is defined. Historically, trust in data environments was anchored around two primary areas, which you see on left side of the slide. The first one is of course the pipeline reliability. The organizations focused on infrastructure metrics, job success rates, uptime, data freshness, and latency. But if the pipelines ran successfully and data arrived on time, the systems was considered healthy. Now the second one is the important thing, which is the data quality. So static checks on rows, columns, completeness, schemas, uniqueness, and formed actually the baseline definition of trusted data. Both of these remain necessary, but they were designed for analytics environments where humans interpret results. So AI actually changes this fundamentally. So AI does not just consume data; it operationalizes the data. It just turns data into decisions, and once decisions are automated or scaled, trust shifts from the dataset level to outcome level. So this is why the right side of the slide introduces the decision defensibility as the new goal. So trust is now defined by whether a decision can be explained, whether it can be justified, and whether it can be validated in a business context. So this includes three major important dimensions. First one is explainability. So the explainability and context, the organizations must understand why a decision was made and what data influenced by it. And second one is safety and bias checks. So decisions must be evaluated not only for accuracy but also for the fairness and risk implications. And third, the business outcomes verification. So a model can be mathematically correct, but it still produces the outcomes that are operationally undesired. So the bottom right quadrant highlights the another important insights, which is the model performance alone is insufficient. So statistical accuracy metrics such as F1 score or AUC evaluate model behavior is in isolation. So not whether the decision can be trusted in production environments. So now let's discuss why the shift is happening. You see the explanation on the right side of the slide. Dataset assurances alone is no longer enough. Perfect quality scores do not guarantee trustworthy outcomes, and if the data is used incorrectly or interpreted without context. So second, risk varies by context. The same dataset may be acceptable for reporting but insufficient for automated decision making. Trust requirements increases as business impact increases. And finally, defensibility is becoming mandatory. And organizations, they actually increasingly need to explain AI decisions to regulators, customers, and internal stakeholders. So without lineage and contextual visibility, that becomes impossible. So we are actually moving from asking is the data is correct to asking can we defend the decision produced from this data. So and once the trust is defined at the decision level, it can no longer be violated once. It must be continuously maintained, and that this actually brings us to the next shift, which is continuous trust validation. Next slide, Arish. Yeah. So data without context cannot support AI decisions. So at this stage, we discussed ownership fragmentation, traceability challenges, and why trust is shifting towards decision defensibility and continuous validation. So this slide introduces actually another critical realization, and this is where many AI initiatives quietly fail. So AI model process patterns; they do not understand a meaning, and that distinction is extremely important. So AI systems learn corrections from the data, and they do not inherently understand decisions, business intent, and operational definitions or organizational context. Without those context layers, enterprise data can easily become a source of incorrect conclusions rather than insight. So this is why we describe context as a foundational requirement for trustworthy AI. So if you look at the slide here, there are mainly three context layers that our organization must establish. So first one is the business meaning. So at the foundation of data is business meaning. The data fields often look technically correct but represent different business concepts depending on how they are defined. So for example, let's say in consumer analytics, terms like churn rate, attrition rate, or inactive customer, they may be used interchangeably across teams, but they often represent different definitions. If those definitions are not clearly codified, models actually learn inconsistent signals. The AI optimizes for patterns that may not align with the business intent. So this actually creates what we call as missing context risk. So the model may perform well mathematically, but it optimizes for the wrong outcome. Over time, this leads to strategic misalignment where AI decisions appear correct technically but incorrect from a business perspective. Second one is transformation history. As the data moves through pipelines, it is filtered, aggregated, enriched, and reshaped. But these transformations are necessary, but they also introduce some assumptions, right? So without visibility, how data was modified, organizations lose the ability to understand feature logic and upstream dependencies. So let's say, for an example, let's say a filtering rule introduced years ago for reporting efficiency may unintentionally exclude certain customer segments. So when AI models are trained on this data, the exclusion becomes embedded as reality. So this actually creates a hidden bias risk shown on the slide. The model does not know the bias exists. It simply learns from the data it receives. This is why operational context is critical, and organizations must understand not only what data exists but how it become what it is today. Now the third one is source traceability. Organizations they must know where data originated and who owns it, and whether it is appropriate for intended use cases. This becomes especially important as systems increasingly combine internal data with external or generated data sources. So without provenance, organizations face explainability risk, and they may be unable to verify whether restricted data or sensitive information or unverified sources influence model decisions. So context is what connects data quality to decision trust. So data may be complete, accurate, and timely, but without meaning, transformation visibility and source traceability, AI systems cannot interpret it correctly. So in other words, data without context creates confidence but unreliable decisions. So because ultimately AI trust is not created by better models, but it is created by better context around it. Over to you, Amandeep.
Perfect, Arun. I think that brings completely to my slide is that actually AI trust requires shared accountability. So earlier we discussed, I threw some light upon how trust breaks because of responsibilities distributed, but and also accountability is shared. In this slide, I want to show the shift that is required. Scaling AI reliably means moving from siloed hands-off to joint ownership of outcomes, because trust cannot be passed from team to team. It must operate as a shared protocol across data, AI, risk, and entire business functions. So if you see at the foundation, it is data integrity, which includes quality, context, and lineage. Data team still owns the infrastructure, but AI teams validate fitness for modeling, risk teams monitor policy alignment, and business users confirm the real world meaning. The next is model reliability. Here, performance, drift, and operations are checked, because AI teams owns the models, but the data teams support upstream consistency. Risk teams actually audit the thresholds, and business stakeholders confirm alignment with expectations. And then comes ethical compliance. Now this is very important because it focuses on biasness, fairness, and privacy. Instead of late stage gatekeeping, controls are embedded across the infrastructure, so it would work out well. And finally, outcome trust. Data must be ready, models must be validated, and risk must be clear. Only then is business value verified. And the message here is very simple, because that AI cannot belong to a single function. It must be collaboratively engineered. And when accountability becomes shared, trust stops actually breaking at hands off, and it becomes a part of how decisions are produced.
Next slide, Anish. Yeah, so at this stage, we reach an important conclusion. After discussing ownership gaps, traceability issues, context loss, and continuous validation, many organizations assume the solution is more tools. But across enterprises, the real concern isn't technology. It's actually the operating model. If you look at the bottom layer of the slide, most organizations, they have already modernized their infrastructure. But they have introduced lakehouses, pipelines, and compute are in place. But AI is technically possible. Yet the trust challenges remain, which tells us the problems sits about technology in how teams operate around data and decisions. So at the top, the goal is clear: reliable AI predictions and automated decisions. But those outcomes depend on the middle layer, the operating model. And this is actually what we call as the trust engine. So there are three elements define this shift. First one is, of course, the process alignment. The trust checks must be embedded into the life cycle, not added at the end. And the validations and governance become part of how work happens. And second one, the shared ownerships. The trust breaks in handoffs, but the organizations, they must move from siloed functions to joint accountability for decision outcomes. That one is active governance. So governance, they actually move from documentation to automation, and policies as code and continuous monitoring that keeps pace with AI velocity. So the executive inside is actually simple. Most of the organizations, they have solved the tech layer, but the failure point is the operating layer. So AI trust isn't created by adding tools. It's actually created by aligning process, ownership, and governance around outcomes. So technology enables AI, but the operating models, they actually makes the AI layer. So that brings us to the next slide. So we are now moving towards the final part of the discussion, and the focus shifts from diagnosis to execution. So this slide actually represents what we consider the new standard AI-ready data, the new standards for the AI-ready data, and that standard is operational reliability rather than just technical correctness. So for many years, operations equated, for many years, the organizations, they actually equated AI readiness with modern infrastructure, centralized platforms, and improved data quality process. But however, as AI systems increasingly move from supporting insight to driving automated decisions. So these definitions of readiness must evolve beyond availability and accuracy towards sustained, dependable performance under real operational conditions. So you can see the first element is the continuous quality validation. So which reflects actually a shift away from periodic batch-based data checks towards the real-time validation streams, which are actually capable of identifying anomalies before they propagate models that affect downstream decisions. So the second element here, it is actually the end-to-end lineage visibility. So which actually ensures that every data point flowing into a model, whether it is a feature vector, embedding, or derived metric, or which can be tracked back to its original source and transformation logic. So the third layer That element, which is actually within the technical foundation, is context and metadata availability. It actually requires embedding business business definitions, semantic meaning, and domain logic that directly alongside the data itself. So, AI systems and downstream consumers do not misinterpret the fields, the aggregates, or classifications. So, however, the technical mechanics alone do not create trust, which is why the right side of the slide introduces the trust assurance as the governance layer that elevates reliability from a technical capability to an organization commitment. So, first dimension is the trust assurance is that user accountability. So it is actually means the clearly assigning responsibility not only for managing pipelines but also for understanding and owning data that influences AI outcomes. And the second one is defining trust expectations, which involves establishing data SLAs that measure reliability characteristics such as inconsistency timelines, completeness, and contextual accuracy. So this is why the quote at the bottom of the slide captures the essence of the shift. Reliability is the new quality because in a world of automated decisions, data that is merely accurate but not repeatable under operational pressure is insufficient. Okay.
Thank you so much, Arun. Anish, next slide. Yeah. So at this point, the conversation shifts from actually fixing the trust issues to redefining success in AI era, because for years, enterprise data strategy focused on platforms, more modernizing availability and adoption, but investments in lakehouse and pipelines, catalogs, and security were very necessary. But AI changed the objective. Here, the goal is no longer the platform, it's the outcome AI delivers. And at the top of the slide, the focus is clear: business impact and reliability decisions. AI creates value only when decisions are trusted enough to scale operationally. And this requires a new operating model. So let me run you through it very quick. First, treat the data as product with clear ownership, SLAs, and continuous improvement. Second, you need to focus on shift towards accountability to outcome, not just pipelines or models, but whether decisions deliver real business results. That should be the focus. And third, move to cross-functional execution, because joint team across the data, AI, risk, and business instead of siloed hands-off. So this is important. In simple terms, we need to move from managing platform to engineering trusted AI outcomes, and then that's when AI becomes a business capability and not just a technology initiative that you put as a top of the layer. I don't know what to you.
Yeah. Yes, Anish. So as we close this session, let me summarize the key ideas we have discussed today from an executive perspective. So, the first takeaway is the AI exposes fragility, and the AI does not introduce new data problems, but it amplifies the existing ones. And second one is, the scale does not equal trust. The modern platforms, they have actually solved and scalability challenges, but they have not solved confidence. So, and third one is, the governance must evolve, and the manual stewardship and document-driven governance cannot keep pace with AI velocity. And finally, the real decision is operation. The biggest barrier to trust AI is not technology. Most organizations already have the tools. The challenge lies in operating the models. Okay, Amandeep.
Yeah. Anish, I think we are done. Over to you.
Well, thank you, Arun, and thank you, Amandeep, for taking us through such an insightful session. Well, honestly, I'm sure listening to the importance of data, especially in the AI era, is something that our viewers have been waiting to see and waiting to listen to you guys. Well, as we are towards the end of the session, I want to sincerely thank all of you who's been spending the last 1 hour listening to both Aman and Arun on sharing their insights and being a part of our important decision today. Well, to conclude, as they mentioned, data trust is no longer a technical aspiration, and it's a foundational requirement to scaling AI with accountability, of course. With that, I would like to thank once again Amandeep, Arun for sharing their research insights and practical guidance. Your perspectives continue to help data leaders navigate real operational constraints with clarity and confidence. And to all our audience who's been spending the last 1 hour with us, your engagement is something that is running our webinars on a regular basis, and look forward to all our upcoming sessions on our website as well as on our LinkedIn, and we look forward to seeing you all in upcoming sessions. With that, have a great evening, and for some of you, have a very good morning, good day to all of you. Thank you, guys.
Thank you so much, guys. Have a good day.